Today, let's review for exam 3. Question 1. Use the vertical line test to determine if this graph represents a function or not. According to the vertical line test, if we can draw vertical lines that intersect the graph at more than one point, it is not a function. And you can see for every single vertical line, we cannot do that. We can only intersect it once. Therefore, this is a function. This is a function. Question 2, again we'll use the vertical line test to determine if this graph represents a function or not. Every single vertical line that I can do will never intersect more than once. So this is again a function. We can only intersect it once. This is a function. In example 3, we have a different scenario. If I can draw a vertical line that intersects more than once, we have an intersection here twice, for any vertical line, this is not a function. It's disqualified as a function. So we just need to find one that intersects more than once, and this is not a function. In example 4, this is a cubic function, but if you look carefully, every single vertical line that I can possibly imagine will only intersect once, so we have a function. Example 5, evaluate f of x equal negative 5x plus 29 for f of 6n minus 5. The first step is to write f of 6n minus 5. You're telling the reader what you're going to do. And this means we're going to take the 6n minus 5. Going to substitute that into the variable for x. That's what we're doing. We can now write negative 5, and we'll do the substitution with 6n minus 5. And we'll add the 29. So that's all we're doing. We're doing substitution and then simplifying. We need to distribute now. Negative 5 times 6n is negative 30n. Negative 5 times negative 5, that's a positive 25. And then we have a positive 29. We'll simplify a little bit further, bring down the negative 30n, and then we'll add 25 plus 29. That gives us a positive 54, and this is our solution. We make sure our equal signs are lined up from top to bottom, and we show our work on each step. Example 6, again we're doing a substitution problem. We're going to evaluate this for x equals negative 5. I have to write f of negative 5 first to tell the reader what we're doing. And we're going to substitute that negative 5 into every single place we see an x. This is 7 times negative 5 squared plus 7 times negative 5 minus 6. According to our orders of operation, we'll do the squared term first. Negative 5 squared, that's going to give me a positive 25. The next step in orders of operations is multiplication. So let's multiply 7 times 25. That gives me 175. 7 times negative 5 is negative 35 minus 6. After simplifying, subtracting all of these numbers, we get 134. Again, make sure you write f of negative 5 in the beginning just once and line up all of your equal signs. This is a good solution. Example 7. We need to again write f of negative 3 first before we do the substitution. We're going to plug in a negative 3 into everywhere we see an x. This is 9 times negative 3 squared plus 2 times negative 3 minus 3. Again, the exponents come first. We'll do negative 3 squared, which is a positive 9. And now I can multiply from left to right. 9 times 9, that's 81. 2 times negative 3 is negative 6. And then we have a negative 3. Simplifying all of this, we get our solution is 72. Question 8. Use the graph to determine the linear function f of x on the graph. The first step is to find where these points are located. And the first point is located at 1, 1. For the second one, we have to be more careful. This is 1, 2, 3, 4. So the first ordered pair is 4, comma. And we have to go down 1, 2, 3. So this is the ordered pair 4, 3. To find the equation of our line, we write f of x is equal to mx plus b, where m represents the slope and b represents the y-intercept. And the formula for the slope is y2 minus y1 divided by x2 minus x1. So we'll look for the slope first. I'll label this as x1, y1, and we'll label this as x2, y2. Now, I made a mistake here. It should have been a negative 3. So let's make sure we fix that. This is 4, negative 3. Let's find our slope. M equals y2, which would be negative 3, minus y1, which is 1, divided by x2, which is 4, minus x1, which is 1. We have our slope is now negative 4 divided by 3, or negative 4/3. This is our slope. And that looks exactly right. If you count, you'll go down 4 spaces, and to the right 3, you'll end up at the graph again. So if you go with the rise of negative 4, 1, 2, 3, 4, the run is indeed 3. So we did it right. The slope is negative 4 over 3. Then we'll plug it into our formula, f of x equals mx plus b. And so this becomes f of x equals negative 4/3 x plus b. We're almost done. We need to find the y-intercept. And you can't just read it off the graph. It's unclear. So I'll use this ordered pair 1, 1. I know f of 1 means substitute a 1 into the equation. But f of 1 is supposed to be equal to 1. That's what 1, 1 represents. 1, 1 implies f of 1 equals 1. The input is 1, the output is 1. So I can say that this is 1 equals negative 4/3 plus b. We'll add that 4/3 to both sides. And so we have 1 plus 4/3 is equal to b. And we could rewrite 1 by multiplying the top and bottom by 3 to get common denominators. So b simplifies to 7 over 3. 3 plus 4 gives me the 7, and the denominator is 3. So that's our b. We have the b and we have the m. To finish off the problem, we'll write our solution in the slope-intercept form. And that's it. We have f of x equals negative 4/3 x plus 7/3. Example 9, a car rental company charges a base fee for each car rented, in addition to a fee for each mile driven. If a person drives a car for 150 miles, the total charge is $47.50. If a person drives a car for 200 miles, the total charge is $60. Find a linear function f of x equals mx plus b, whose input is the miles driven and whose output is the corresponding total charge. The first step is to realize that we have ordered pairs here. 150, comma 47.50 is our first ordered pair. And for the second one, we have 200, comma 60. We can label this because they actually represent points on a line. We have x1, y1, and we'll call this x2, y2. We can find our slope using the same formula, y2 minus y1 over x2 minus x1. And so this gives me 60 minus 47.50 divided by 200 minus 150. The numerator simplifies to 12.5, and in the denominator we have that's 50. And so this is equal to 0.25. That's our slope. And now we can rewrite our function. F of x equals mx plus b is now f of x equals 0.25x plus b. We're almost done. We need to find the b. So I'll use any point that I want. I'm going to use this one because it has nice whole numbers. This ordered pair implies f of 200 should get a total charge of 60. So f of 200 should be equal to 60. F of 200 means I need to substitute that 200 into my equation, but f of 200 is 60. So 60 equals 0.25 times 200, which is 50 plus b. And we can subtract that 50 to both sides now. Subtract 50 to both sides, and b equals 10. That means our equation, let's piece it together, is f of x equals 0.25x plus 10. That's it for part A. Now let's look at part B. Part B says explain what the slope and what the y-intercept represents. The slope represents the cost per mile. So in this case, it costs us 25 cents per mile. Now what's the y-intercept? The y-intercept is 10. The y-intercept here is the base fee. So it costs us $10 to rent this vehicle, and we're going to be charged 25 cents per mile. The y-intercept again is the base fee. We have one more part to this question, part C. It says use the formula from part A to determine how much it will cost if we drive 110 miles. That means we need to plug in 110 into our equation here for f of x. So we'll do that here. F of 110 equals 0.25 times 110 plus 10. And that gives us $37.50. So make sure you write your answer in dollars. So this is $37.50 that it will cost us to drive 110 miles. And just a quick double check. Let's see if that's reasonable. Well, if we drive 150 miles, the cost is $47.50. So our cost here should be less than $47.50, and let's make sure, and it is. So we know our answer is pretty reasonable. In example 10, the first step is to realize the vertex form of a parabola is x minus h squared plus k tells us the vertex right away. We know the vertex is the ordered pair h, comma, k. So in this case, our vertex is positive 7 and negative 1. Again, there's a negative here, so whatever is after that negative is the h, and the h is positive 7. That's our vertex, 7 comma negative 1. So we'll graph that first. And this is the point, 7 comma negative 1. The next step is to look at the parent graph. Recall the parent graph for a parabola is as follows. We have negative 2 squared is positive 4, negative 1 squared is a positive 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So this is the general shape for the x squared function or the parabola. And that tells me how to graph this. This means go to the left 2 from the vertex. We're going to go up 4 units. Left 2, up 4. So that's 1, 2, 3, 4. So this is our second point. The second order, negative 1, positive 1, which means we go left 1 and then up 1. And then 0, 0, that's our vertex. 1 comma 1, that's our fourth point, and we can find a fifth point easily. Go to the right 2, up 4 units. And this is nice because we can already see our x-intercepts. We can write that down. Our x-intercepts is the point 6 comma 0, and we have another one here. It's the point 8 comma 0. We have the vertex, we have our x-intercepts, and now we need to find the y-intercept. To find the y-intercept, we let x be equal to 0. So we'll look at the original equation here, and we're going to plug in a 0 for the x. F of 0 equals 0 minus 7 squared minus 1. And that gives me 49 minus 1, or 48. And so that means our x-intercept, that means our y-intercept is the point 0 comma 48. And that's our y-intercept. Well, unfortunately, we can't graph the y-intercept because it's way off the chart, but we can still sketch our parabola. Let's do the sketch. And it's going to look like this. We just need to be careful, make sure it's not a sharp corner, it's a smooth U shape. We'll finish off the problem by stating the domain and the range. The domain is how far left it goes to how far right it goes, and in this case is negative infinity to infinity. The range is how far down to how far up. It drops down to a negative 1 and it goes up forever. That's our range. Question 11, let's graph this function again. And recall that vertex form is x minus h squared plus k. So our particular problem has a vertex at negative 6 and positive 4. Again, since this is a positive, I can pretend that's a double negative. So my h is actually a negative 6. Let's start by plotting the vertex negative 6 comma 4. And this is the point negative 6 comma 4. Now we can look at the parent graph for the squared function. Again, that's negative 1, 0, or we'll start with negative 2. That's negative 2, negative 1, 0, 1, 2. This is just some random points for the x squared function, so we can see the general shape. We have 4, a 1, a 0, a 1, and a 4. Now that means I can go left 2, up 4 if it was a standard parabola. But notice something here. There's a negative. There's a negative in the front. And what does that do to our standard parabola? It flips it upside down. So we're not going to have one of these regular U's. It's going to be something like this. It's going to be flipped upside down. So all of these are going to be opposite of what they were originally. We're going to go left 2, and instead of going up 4, we're going to go down 4. So we'll go down 1, 2, 3, 4. Left 1, down 1. From the vertex, you always restart from the vertex. Right 1, down 1. Instead of up 1, that's the opposite. And right 2, down 4. And we got lucky again. We can actually read off the x-intercepts. The x-intercepts are located at these 2 points here. The first one is 8, 0, or negative 8, 0, and the other one is negative 4, 0. So we have 2 x-intercepts. To find the y-intercept, you're going to let x be equal to 0 in the original function. So we're going to plug in a 0 for the x here. F of 0 equals negative 0 plus 6 squared. This simplifies to negative 36 plus 4, or negative 32. What does that mean? That means our y-intercept is the ordered pair 0, negative 32. And unfortunately on this graph we cannot plot 0, negative 32, but it still gives us a general idea of our graph. And so we'll finish off this with our parabola. We'll state the domain and the range now. The domain is how far left and how far right it goes. It goes negative infinity to the left, positive infinity to the right. How far down does this graph go? It goes down to negative infinity, and it goes up to this point. The highest point is a 4. And we're going to use a square bracket because it reaches 4. It's included.